Okay, so I'm back again with another elastic collision experiment in this series of analysis videos on elastic collisions. So I'm going to have this series on elastic collisions and also on spring explosion experiments and also probably on elastic collisions. So I know this is becoming kind of boring and repetitive, but it is necessary. We need as many experiments as possible because the opposition has been asking for a pool of evidence. Now, the main point of this series is to prove ultimately, okay, that momentum needs to be treated as a vector, that there is a distinction between momentum and kinetic energy. So at the end, I'm going to make a compilation chart where I will put all the results, all the experimental results of all the videos that I have analyzed, right? I'm going to put them in one, if they fit on one paper, I'm going to put them in one paper, and then next to it, the mathematical predictions of the velocity before collision, after collision, etc., and draft trans models. So it's going to be momentum treated as a vector and momentum treated as scalar, where there is no difference between momentum and energy. Now, until now, it already is clear that momentum needs to be treated as a vector because before the event, I mean the momentum before the event and after the event, if we add the momentum together after the event, that is always going to be more than the momentum before the event. Of course, in the case where momentum, where one card or one object goes in the opposite direction. In that case, there is always going to be free energy, always, okay? Especially if we add more mass to one card, the momentum will only become bigger and bigger, and there's going to be more energy, more free energy. Whereas if we treat it as negative, and we do negative plus positive, then momentum is conserved. Okay, so up to the video, this is the same person as in my last video, but now he has added 500 extra grams to the blue part. So in the previous one, we had 275. 275 versus 525. Now we have 275 kilograms versus 775 kilograms. So let's take a look.
Je wordt minder snelheid overgegeven. Dat de massa op lange kantje nog groter is geworden. Nou, dan gaan we dan even kijken.
So it's going to record and do the collision. There we go. Now we have the data on the graph. It's going to filter out. Yes.
Het rode karretje heeft 0,65 meter per seconde.
So he says the initial velocity of the red card is 0.65 meters per second. So over here, 0.65 meters per second.
Blauwe karretje krijgt dan 0,33.
And the blue card after collision is 0.33 meters per second. You can kind of see it. Here we have, here's the zero line. You have 0.05, 0.10, 0.15, 0.20, 0.25, 0.30, and it's over here. So it's about 33, almost 35. So 0.33 meters per second for the blue card after collision. And the reflection of the red card after collision, he doesn't say it, but we're going to have to look at it ourselves. So it's just going to be this line over here. So we have minus 0.05, 0.10, 0.15, 0.20, 0.25, and it seems to be like almost 0.30. I've written 0.29, 0.29, 0.30. So that's our data. Now we can do the predictions with this formula. Again, this is the exact same formula that Professor Lewin uses. Well, all over the world in every science class. they will use this formula to predict the velocities after collision. So what happens? So the prediction for cart 1 after collision, so the reflection velocity, the prediction is 0.30 meters per second, and the result is 0.29, 0.30, which is almost perfectly correct. Okay, so now the blue card, the heavy card, the 775 kilograms card after collision, the prediction is that it will continue to go in that direction with a velocity of 0.34 meters per second, and the result is 0.33 meters per second. Again, very, very close. Then we're going to look at the momentum. Is momentum conserved or not? Momentum of part 1, the initial momentum before collision is 0.178 kilograms meters per second. Part 1 after reflection, the momentum is minus 0.079 kilograms meters per second, and the blue card after collision, momentum is positive 0.255 kilograms meters per second. So if we are treating the opposite direction as a negative value, then the total combined momentum of both cars after collision is equals 0.176 kilograms meters per second. So we have 0.176 versus 0.178. Very close. The difference is only 1.12%. Okay, it's a very good result. They match really good. Small difference. Momentum is pretty much conserved. Okay, so now let's add them together. Let's treat momentum as a scalar, okay? Because momentum is energy, okay? According to the opposition, momentum is energy. Let's add them together. 0.079 plus 0.255 equals 0.334. So we have 0.334 versus 0.178. The difference is 87.64%. So we have an increase of 87.64% of energy. 87% extra energy coming out of nowhere. Wow. How the hell is that possible? That shouldn't be possible. That's absolutely insane. This is a free momentum, free energy generating system thing. It's can't be possible, so therefore there must be something wrong with this experiment. Once again, the 7th time in a row, 7 experiments already that must be broken, that must be done wrong, that must be manipulated or done so badly. But you know what? If they are done so badly, then why the hell each time do the combined momentums match the initial momentum so well? I mean, if it's done badly, it must have total random numbers. But no, they match. And also these predictions, look, they match perfectly, almost. Okay. Let's take a look at the kinetic energy. The initial kinetic energy is 0.58 joules. The combined kinetic energy after collision of part 1 and part 2 equals 0.053 joules, which is a difference of 0.005 joules, which is a difference of 8.6%. Well, pretty small difference, Okay, yeah, it's bigger than the 1.12%, but okay. It's definitely not as big as 87.64%. So according to conventional science, the kinetic energy, the total energy difference before collision and after collision is only 8.6%. According to draft science model, the energy difference between before collision and after collision is 87.64%. All right, that's it. And that's all you need to know. And I'm gonna look for the next experiment and continue doing this as long as it is as it is needed. So